Welcome to the virtual tour of the University of Akron School of Polymer Science and Polymer Engineering. From rubber to sustainable polymers, our researchers have been leading the field for more than a century. We offer cutting-edge academic and research programs in polymer chemistry, physics and engineering, with doctoral and master's degrees and an undergraduate minor. We will start our tour in the 146,000 square foot Goodyear Polymer Center, which houses researchers in polymer chemistry and polymer physics, as well as UA's Office of Technology Transfer. Built in 1991, it features 12-story and 9-story towers connected by glass-enclosed walkways that serve as areas for informal meetings and discussions. The building houses classrooms, research and teaching labs, and offices arranged in clusters for students, visiting researchers, and postdoctoral students. In this building are state-of-the-art polymer characterization and processing facilities for research, training, and testing, which is managed by PhD-level research scientists. Faculty research labs work on breakthrough technologies in areas such as energy, biomaterials, and sustainability. Dr. James Egan's group is focused on synthesis routes to make the world's two most abundant plastics recyclable without the need for expensive and difficult sorting. This is key to solving the global challenge in the life cycle of polymer products and unlocking the circular economy. Dr. Ali Dinaswala's lab focuses on biomimicry, or materials inspired by nature. Studying gecko footpads and spiders reveal more about the natural world while also providing blueprints to better synthetic adhesives. The Dinaswala Spectroscopy Lab uses custom laser lines and instrumentation to study the interfacial science effects like adhesion, friction, and wetting. More recently, research into structural color, or color based on light scattering from microscopic features, has become another facet of this bio-inspired lab. The Polymer Modeling and Data Visualization Center is a high-tech conference space designed to showcase computational research. A composite 170-inch display dominates the back wall, while two touchscreen-enabled displays are arranged along the side. A conference table with 8 integrated workstations gives users the ability to examine models on their own, as well as enables small class instruction in modeling techniques. The 32,000 square foot Polymer Engineering Academic Center is where you will find the student, faculty, and administrative offices of the Polymer Engineering program and the Akron Global Polymer Academy. The 4-story building is home to graduate students and postdocs in polymer engineering, as well as faculty and staff. The student offices here provide space outside the lab where our graduate researchers can discuss their projects, share ideas, and work. The Sidney L. Olsen Research Center, adjacent to the Polymer Engineering Academic Center, houses the majority of polymer engineering labs, as well as some lab space for the biomedical engineering department. Much of the instrumentation located in the center is available to all researchers on campus, including what is available in the Olsen Rheology and Thermal Analysis Lab. Multiple rheometers examine the melt and flow behavior of the polymers produced by the research groups. The thermal equipment helps characterize material structure, mechanical behavior, and even at what temperature the materials begin to break down. The National Polymer Innovation Center is the newest building in the school, with construction completed in 2010. The center, which earned a Silver LEED Award for sustainability, houses both pilot-scale, roll-to-roll film manufacturing lines, and advanced materials characterization techniques. It serves not just internal researchers, but is also available to industry for contract testing and processing work. The electromagnetic processing line is a roll-to-roll line capable of orienting particles in a cast solution using electric and magnetic fields, then curing the particles in place with UV light. The multi-layer film co-extrusion line can produce single-layer films or films with up to 3 separate material layers. Film properties can be further tailored through stretching and thermal annealing farther downstream. The biaxial stretcher characterizes the material properties of polymer films in 2 directions at once, accessing information unavailable through traditional, universal test frame techniques. It is capable of both simultaneous and sequential stretching of polymer films. There are many other advanced materials characterization techniques within the center, covering elemental analysis, microstructure characterization, nanoscale imaging, material fingerprinting, and more. As you can see, the University of Akron School of Polymer Science and Polymer Engineering is a world-renowned institution that prepares students to become leaders in polymer science and polymer engineering. That concludes our tour. Thank you for watching.